Section 5.3 is on inequalities in one triangle. The exterior angle inequality theorem says that the measure of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. So given this triangle here, angle 4 is an exterior angle, and angles 1 and 2 are the remote interior angles. The exterior angle inequality theorem says that the measure of angle 4 is greater than the measure of angle 1, and that the measure of angle 4 is greater than the measure of angle 2. So let's take a look at an example here. Here we have a triangle with several rays going through it, and we need to, for number 1, list all of the angles that are less than the measure of angle 4. So what I'd like to do is look for the triangle for which angle 4 is an exterior angle. And I think that would be this triangle right here, kind of on the top. The triangle that has angles 1, 2, and 3 marked in it. So 4 would be an exterior angle for that triangle. So the angles that would be less than that are angles 1 and 2, because they are remote interior angles. So angle 1 and angle 2 are less than the measure of angle 4. Now angle 3 might be, but we don't know the exact measure of angle 4, nor do we know the exact measure of angle 3, but we do know they're supplementary. So we have to work off of the exterior angle inequality theorem that says that this exterior angle is less than either of the remote interiors. Let's look number 2 for an angles that are greater than angle 7. So angles that would be greater than angle 7 would be anything that would be an exterior angle for this triangle right here, the triangle that 7 is in. So 9 would clearly be an exterior angle for that triangle, so that would be greater than 7. 5 would also be an exterior angle for that triangle. So I'm noticing that this would be the extension and 7 would be a remote interior. And then I think angle 3 is also, because if we're looking at this triangle here that has the 7, 8, and 9, and this extension of the side, 3 would be an exterior angle for this triangle, and 7 and 8 would be the remote interiors. So angle 3 would also be greater than the measure of angle 7. Number 3, what angles are greater than angle 2? That have a measure greater than angle 2. So angle 2 would be the remote interior, would be a remote interior of this triangle, and 4 would be an exterior angle. Also for this triangle, if we were to extend this side here, 6 would be an exterior angle. So it would also have to be angle 6. Oops. And angle 9 is also, now if you're looking at the very large triangle here that has angle 8, and then the third angle is made up of 2 and 7, angle 9 would have to be larger because these two angles right here would form a remote interior angle of the large triangle, so angle 9 would also have to be greater than angle 2. And then all the angles that are less than the measure of angle 9. So 9 is an exterior angle for this smaller triangle down here. So 9 would have to be greater than 6 and 7. So angle 6 and angle 7 are less than angle 9. And then also looking at the very large triangle, angle 9 is an exterior angle for that. So 1 and 2 as well. Theorem. In a triangle, the longest side is opposite the largest angle, and the shortest side is opposite the smallest angle. Kind of makes sense. So the longest side of the triangle is going to be opposite the largest angle, and the shortest side of the triangle is going to be opposite the smallest angle. So for example, given triangle ABC here, since the length of BC is greater than the length of AC, since 9 is greater than 7, then the measure of angle A is going to be greater than the measure of angle B, because angle A is opposite a side of 9, and angle B is opposite a side of 7. In triangle DEF here, since the measure of angle D, which is 120 degrees, is greater than the measure of angle E, which is 30 degrees, segment EF is going to be greater than the length of segment DF. Notice that segment EF is opposite a 120 degree angle, and segment DF is actually opposite a 30 degree angle. So the longer side is opposite the larger angle. Let's take a look at an example here. So this says list the angles of triangle ABC in order from the smallest to the largest. So in order to list the angles from smallest to largest, I need to figure out which side's the shortest and which side is the longest. So in this triangle, 3.7 is the length of AC, so the angle opposite that is going to be angle B. So angle B is going to be the smallest angle. Then kind of the medium length side is 4.8, that's AB, which is opposite angle C. So angle C is going to be my middle angle. And then my largest angle is going to be opposite the side that's marked 7, and that's going to be angle A. And now let's do it the other way around. List the sides of triangle ABC in order from the shortest to the longest. So the shortest side is going to be opposite the smallest angle. And in this triangle, angle B is the shortest side, or the smallest angle. So it's going to be across from the shortest side. So the shortest side is AC. And then the next smallest angle is 55, angle C down here, and that's opposite AB. And then the largest angle is angle A at 80 degrees, and that is opposite side BC. So the sides of ABC in order from shortest to longest are AC, AB, and BC.